Okay, hello everyone again, and I started recording this class, so if you have an issue with that, please let me know. Otherwise, I will keep recording and will post it on the page for the classroom. So in the previous three lectures, we completed the nodal analysis technique, nodal voltages technique, where we found the voltages at the essential nodes. And after having the voltages, you can calculate the current in any branch, and then you calculate the power associated with any of the circuit elements. And today we will start a new technique, which is the mesh analysis technique. But before starting that, let's recall this slide from the previous week. And in order to, let's say, review the terminology that will be needed in today's technique. So as you see here, we have a planar circuit and an unplanar circuit. And an unplanar circuit is that circuit that cannot be redrawn without intersections of lines. So if you can redraw any circuit without any intersection of two lines, so this circuit will be a planar. So we can have it on a plane. But if the circuit will be like this with a crossing line, so this will be an unplanar circuit. So for the nodal voltages technique that we already completed or finished, doesn't matter whether the circuit is a planar or non-planar. So the voltage technique is a nodal voltage technique is suitable for all types of circuits. But for today's technique, the mesh analysis technique or mesh currents technique, we need to make sure that the circuit is planar. If the circuit is non-planar, we will not be able to apply the mesh and mesh current technique. Another issue, we will be using the terminology branch and essential branch. And here I want to remind you that the branch is a path that connects two nodes. So any two nodes, this is a branch, this is another branch, this is one branch, this is also branch, this is also branch, and so on. So for example, R1. So R1 here is a branch. Between A and B is a branch. And we have another terminology, which is essential branch. And the essential branch is a path which connects two essential nodes without passing through an essential node. So, and you remember that the essential node is a node where three or more circuits elements join. So here we have essential node, here we have essential node. This is not essential node. This is essential node. This is not essential node. So if I go from G, which is essential node, to C, which is another essential node, without passing through any essential nodes, so this will be essential branch. So as you see, essential branch can pass through a node, but we need to make sure that this node is not essential. So for example, for the essential node V1, R1, so this voltage source with this resistor, so it will be essential node. Each of them is essential branch. So each of them is branch, but both of them is essential branch from C to B. Is this term clear, please?
Yes.
Okay, and the loop above whose last node is the same as the starting node. So if I go from G to F to C to E and back to G, so this will be a loop. If I go from G to F to A to B and back to G, so this will be another loop. So you need to start from one node and you need to come back to that node. While mesh, which is the most important term here in today's lecture, is a loop that doesn't enclose any other loops inside it. So if I go this loop, so I see that inside this loop, there are no loops. But if I go with this loop, G, F, C, A, B, and back to G, so I see that inside this loop, I have another two loops. So this will be not mesh. So as you see, if I go from G to F, from G to F, from F to C, from C to A, and to B, and back to G, this is a loop. But I see that inside it, I have one loop and here another loop. So this loop, but this is not mesh. So this is a loop, but is not mesh, but the inside is a mesh because inside the inner loop, there are no other loops. So is it clear, please, the concept mesh and loop?
Yes.
Yeah.
Okay, more responses, please.
Yep. Yes.
Okay.
Yeah, it's clear. Yes.
Okay, and lastly, the planar circuit, a circuit that can be drawn on a plane with no crossing branches. So like this, but this is not a planar, although I can take this R and redraw it without the crossing, but I cannot take this R, the other one. I can also draw the other one, this one, and bring it like this, but the other two, this one and this one, it will not be possible to draw them without crossing the other lines. So this is a non-planar circuit, a non-planar circuit. So this is the terminology that we had in the previous week, and we need to recall them because we need to use the essential branch, the mesh, and the planar circuit in today's method, Okay. So once we already recall these, let's say, terms, let me go back to today's presentation. Okay. So this is our method for today, and this is the second method. So the first method was node voltages technique, and now the today's method is mesh current method or mesh current technique or mesh technique. Okay. So the mesh current method of circuit analysis enables us to describe a circuit in terms of BE minus NE minus 1 equations. So let's recall here, please, the nodal voltages analysis. So in the nodal voltages in analysis, we had essential nodes. We have essential nodes number, and we selected one of these essential nodes to be a reference node. So it will be -1, and this number will be the number of the equations based on KCL in order to solve the system. So this was the nodal analysis techniques. Of course, if we don't mention the special cases, when you have a voltage source connected to the reference bus, or when you have a voltage source connected between two essential nodes. So that will be a super node, or you will have one of the voltages is at the essential nodes node. Sorry. So the number of equations in the nodal voltages analysis is equal to NE minus 1. And it will be based, these equations will be based on KCL, which is Kirchhoff's current law, which states that the algebraic sum of the currents entering any node is equal to 0. And the NE is essential nodes, and the essential node is that node in which you have 3 or more simple circuit elements connected. So if we look at this figure, please, if we look at this circuit that we have here. So as you see, how many simple circuit elements in this circuit? So in the
8.
how many?
8.
I see 9.
Oh, 9. Sorry.
Yes.
Sorry,
Okay. 9. Okay, so we have 8 resistors, right, and 1 voltage source. Okay, is this a circuit or a network? So what is the difference between the circuit and the network? Any ideas, please? Okay, so network is the interconnection of two or more simple circuit elements, while the circuit is a network that has at least one closed path. So this is a network and at the same time is a circuit. So this is a network and at the same time is a circuit. And I see that I have one response. Okay. So my question was, is this a network or a circuit? And the answer that this is a network, because the definition of the network is an interconnection between two or more simple circuit elements. And here we have 9 of them. We have 9 circuit elements. And then at the same time, it is a circuit because the definition of the circuit is that a network that has at least one closed loop or one closed path. And in this circuit, I see that I have many of the closed path or closed labs. Is it clear, please, the definition of the network and the circuit?
Yeah.
Okay.
Yes.
Okay. Is this circuit active or passive? Is the circuit active or passive? So any responses?
I want to say,
I would say,
active.
I would say active too.
Active, exactly. Why it is active?
Because of the voltage source that
Yes,
Yeah, that's right.
exactly. Because we have at least one source. So whenever as you see, we have 9 circuit elements here, 8 resistances, and the resistances are passive elements. So the passive elements are resistors, inductors, and capacitors. So so far we deal only with the resistors. So I have 8 passive elements, and the source is an active element. So voltage source, current source is an active element. So if you have at least one active element in the circuit, it will be active circuit. Okay, thank you so much. How many nodes in this circuit? So in the chat, I see
6.
6. So we have 6. Okay, let's count them together. 1, 2, 3, this one, 3, this one, 4, this one, 5, and this one, 6. So we have 6 nodes. Thank you all. How many essential nodes we have?
4.
4. And in the chat box, I see 4. So they are 1. We have 3 elements connected. We have another one where we have 4 elements connected, and we have one where 4 elements are connected, and we have one where 3 elements are connected. So we have 4 essential nodes. Okay, so number of essential nodes is equal to 4. If I want to solve this problem using nodal analysis technique or a nodal voltage technique, so how many equations I will have? So I see here in the chat box, it says 3. Exactly 3, because we have 4 essential nodes. We will select one of them to be the reference. Then we will have 3 nodes, and then you write KCL for the 3 non-reference nodes, and then you solve it to find V1, V2, V3, and once you solve it, you will have you can determine the currents in the circuits. Okay. Okay, now let's go and think about our new method. How many branches, essential branches I have? How many essential branches I have? So in the chat box, it says 7. Let's calculate that. So I have one essential branch with 3 simple circuit elements, 1, 2, 3, but it connects 2 essential nodes without passing through an essential node. So it passes through a node here, it passes through another node here, but they are not essential nodes. So this will be one essential branch. This is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. So we have 7 essential branches. Is it clear for all of us, please?
Yes.
Okay. So now we need to apply the formula, which says essential branches, which are 7, minus, in brackets, the essential nodes minus 1, and closing the bracket. So the essential nodes are 4, minus 1, it will be 3, and then 7 minus 3, it will be 4. So if we want to use mesh analysis, then we will have 4 meshes. 4 meshes, and the mesh is that loop which doesn't contain any loop inside it. So this will be one mesh, as you see. This will be another mesh, and this will be third mesh, and this will be the fourth mesh. So we have 4 meshes, 4 meshes. So if I want to solve it using mesh analysis, so I need to have 4 equations, and these equations will be based on KVL, based on KVL. Okay, so the mesh current method will use the essential number of branches, which are 7, minus the essential number of nodes, which are 4, minus 1, then it will be 3, 7 minus 3, then it will be 4. So in order to solve this circuit using mesh current analysis or mesh current method, so we need to have 4 equations with the 4 variables, 4 equations, 4 variables. Recall that a mesh is a loop with no other loops inside it. We already recalled that. Recall also that the mesh current method is applicable only to a planar circuit. So if the circuit is non-planar, so we cannot apply the mesh analysis technique. And this is the main disadvantage of this method, because you cannot apply it for a non-planar circuit. A mesh current is the current that exists only in the perimeter of a mesh. So we have current. So let me go back to the circuit. Let me zoom it. Okay, so we will have a current which is flowing in this loop. So I will start with this. I want to describe I4, okay? So current I4 is flowing in this loop like this, and like this, up through R3, through R2, and back to this one. So this is the mesh that we specified, and we give it number 4. And this is the current, the mesh current, which flow in this loop. So the mesh current is flowing in the perimeter of the mesh or of the loop. Here we have another loop starting from this point or mesh, down up to this point, to the left-hand side, and then up to this point. And we gave it number 3. So we have a mesh current will flow in this mesh. And this mesh current is not the current of R8. It is the current of the mesh, the current which is flowing in the perimeter of the mesh. And similarly for I2, similarly for I1, you can start from this point and back to this point, okay? So the mesh current is that current which flows or exists only in the perimeter of a mesh, Any questions about this slide, please?
Professor, can you just give the significance of the equation in the first point, please?
Yes. So this equation, right?
Yeah, that one, please.
Okay. So if I give you a circuit and I ask you to analyze it, so first of all, you will think what is the most suitable method to do so. Okay, so you by the end of this chapter, you will know 4 different methods. You will know nodal voltages technique that we already done with it. You will know mesh current techniques. You will know Thevenin technique and superposition. Okay, so you will know 4 methods. So in order to select, of course, you will look for the method with the least number of equations and the least number of unknowns. So for a nodal voltages analysis, we already know that the number of equations and the number of unknowns will be the essential nodes minus 1. So for example, in this case, this circuit, we have 4 essential nodes, 4 essential nodes, minus 1, it will be 3. So I can solve this circuit with 3 equations only, based on KCL or based on nodal voltage technique. But if I want to check for another method, for example, the mesh current method, so the number of equations and the number of unknowns will be the essential branches minus the essential nodes minus 1. And in our case here, the essential branches are 7, the essential nodes are 4, then 7 minus 4 minus 1, it will be 4. So if I want to solve it using mesh analysis technique, I need 4 equations, while nodal analysis technique requires 3 equations. So after knowing that, which is the best method for you to go with? What do you think?
So I suppose that the least complex would be to use the node method in this case, right?
Yes, exactly. So this equation will show us how many unknowns we will have and how many equations we will have, exactly as it was for the nodal analysis given as the essential node numbers minus 1. Okay. Did I answer your question?
Yeah, you answered my question. Thank you very much.
You are most welcome. Okay. So, and here we have a simple example that will lead to the concept of the mesh analysis. Okay, so let's see this simple example. So here we have a network because I have more than 2 simple circuit elements interconnected with each other. And this network is also a circuit because I have at least 1 closed path. And this circuit is active because I have 2 sources. And if you have at least 1 source, then the circuit will be active. And I have here 2 essential nodes because this node connects 3 components. This node connects 3 components. So I have 2 essential nodes. So if I want to solve this system using nodal analysis, so the number of the essential nodes is 2, and the essential node minus 1 will be 2 minus 1, and this will be 1. So if you take, for example, this node as the reference and you apply KCL to the upper node, the circuit will be solved, So using nodal analysis will require only 1 equation with only 1 variable, which will be V1. And once you find V1, then you can calculate I1, I2, I3, and so on. So this is if you need to go with the nodal voltage analysis, right? But now we are not thinking about nodal voltage analysis. We need to think of how to find the currents. So in R1, I have a current I1. In R2, I have a current I2. In R3, I have a current I3. And I gave these directions. And I want to find the values of these currents without using nodal voltage technique. I want just to use Ohm's law, KVL, KCL, and try to find the 3 currents. And once I have 3 currents, so I have 3 unknowns, and how many equations I need to find the 3 unknowns. How many equations I need to find three unknowns?
3.
3. So the number of equations should be equal the number of unknowns. Otherwise, the system will not be solved, no matter it is circuit analysis or any other engineering or mathematical problem. So the number of equations should be equal to the number of the unknowns. Okay. So here I need 3 equations. Once I have 3 variables, then I need 3 equations. And these 3 equations, I know 3 laws so far. I know Ohm's law, and I know KCL, which is Kirchhoff's current law, and I know KVL, which is Kirchhoff's voltage law. So I know only these 3 laws. I know only these 3 laws. And actually, Ohm's law is embedded. We use Ohm's law is inside KVL. Because when you write KVL, for example, you write that this voltage is equal to IR1 plus I3R3. So you are using IR. So you are multiplying the current with the resistance. So this is Ohm's law. So Ohm's law, usually we use it inside KVL. So if Ohm's law is embedded inside KVL, then I will have only 2 laws. I need to use only 2 laws, KVL or KCL, in order to find a set of 3 equations. And if you write KCL to the upper node, what will be KCL to the upper node? And they're reminding you that the current entering the node will be negative, the current leaving the node will be positive. So what will be the current, the KCL to the upper node? I'm listening, please.
V2 minus V1 over R1.
No, KCL, let's
Oh.
use the current that we have.
Negative I1 plus
Negative
I3
I1 plus
Mhm.
I3
plus I2 equals 0.
plus I2 equals 0. Thank you so much.
Mhm.
So this is KCL. So we have one current entering the node. So it will be negative I1, sorry. And I have 2 currents leaving the node. So it will be plus I2 plus I3 equal to 0. This is KCL. Okay, what will be KCL to the lower node? What will be KCL to the lower node?
Would that be negative I3
Negative I3, okay.
mm, minus I2?
Negative I2, okay.
I think plus I1.
Plus I1. And this is equal to 0,
0.
right?
Thank you.
Okay, and I see in the chat box, yes, negative I3 plus I1, negative I2 is equal to 0. Thank you. Okay, so if you look at these 2 equations, what do you see? If you look at these 2 equations, what do you see? So the upper equation is negative I1 plus I3 plus I2 is equal to 0. The lower equation is I1 minus I3 minus I2 equal to 0. So what do you think? I see that I have a response same but opposite polarity. Okay, so if I multiply the upper equation by negative 1, I will have the lower equation, right? So if I multiply this equation, both sides by negative 1, so it will be negative I1 plus I3 plus I2 is equal to 0. So practically, these are only one equation. So these are only one equation. So my conclusion is that I can use KCL for this circuit only once, either for the upper node or for the lower node. I cannot say that I have 2 equations because it is practically the same equation, but multiplied with negative 1 both sides. Okay, So then my conclusion is I can bring one equation from KCL. So KCL will give me one equation. And let's go back. So what laws that we are using in circuit analysis? Either KCL or KVL or both of them. I already done with the KCL and I have one equation from KCL to the upper node. And now I have to use KVL with Ohm's law inside it, embedded inside it. So KVL is written for loops. And how many loops here I have in this circuit?
So 2
I have
or 3 technically.
3. We have 3 loops. So we have one loop is the left-hand side, other loop is the right-hand side, and the outer loop, But if you write, for example, the outer loop, your I3 will be excluded, right? So if you write the outer loop. But if I write the left-hand side and the right-hand side loops, all the 3 currents will be included. So now we will write the KVL for this loop. And again, let me remind you, if you go with the direction of voltage drop, it will be positive. If you go with the direction of voltage drop, let's say like this voltage drop, if you go with the direction of voltage rise, it will be negative. Okay. And now I want to write for this loop, and I will start with the V1. Let me magnify the circuit. So I will start with V1. So I'm going in this direction, in the clockwise direction. So V1, it's voltage rise or voltage drop?
Rise.
Rise. So it will be negative V1. Negative V1 plus, we are in the direction of the current, as you see, plus I1 R1 plus I3 R3 equal to 0. So if we see the first, so negative V1 plus I1 R1 plus I3 R3 equal to 0. If you take V1 to the other side of the equation, it will be positive V1. Then V1 is equal to I1 R1 plus I3 R3. Okay, now let's write KVL for the second loop, and let's take the same direction as this. Okay, so if we go to the start with V2, if we go in this direction, V2, it will be voltage drop from the positive to the minus. It will be V2 minus I3 R3. Why it is minus I3 R3?
Opposite side of the current.
Yes, because the current is flowing in the opposite direction of my loop. And the plus I2 R2 and the plus I2 R2. So if we go here to the equation, V2 is plus. When you take it to the other side of the equation, it will be negative V2. So I2 R2 was positive and negative I3 R3 because the current I3 is flowing in the opposite side. Okay. So these are the 3 equations. And as you see, we have 1 KCL and 2 KVL. And the Ohm's law, as you see, this is Ohm's law, right? So Ohm's law is embedded in the KVL. So always we use Ohm's law inside KVL. Okay, so these are the 3 equations. And with these 3 equations, I can solve the circuit easily. Okay. So first of all, let's eliminate the current I3, because as so one of the currents, let's eliminate one of the current, and this will be I3, and I can eliminate it from the first equation, which is the KCL. So from KCL, as you see, I1 is equal to I2 plus I3. And from here, I can say that I3 is equal to I1 minus I2, right? And then I will take this expression and I will substitute it in this part instead of I3, and the same here also. So if I do so, so it will be this I3, it will be I1 minus I2 times R3. So I1 multiplied by R1 and I1 multiplied by R3 here. Then I can take common factor I1, open the brackets, R1 plus R3. And then I will have negative I2 multiplied by I3. So negative I2 times R3. And if you plug this value here, so you will have I2 multiplied by R2 and I2 here multiplied by R3, and negative negative, it will be plus. So I2 will be multiplied by R2 plus R3. So as you see, I2 multiplied by I2 plus I3. And here I1, which is negative I1 multiplied by I3. So negative I1 multiplied by R3. And this is equal to the voltage sources values. So V1, V2 unknown because they are voltage sources. So now I see I1 is unknown, I2 is unknown, and I have two equations with two unknowns, So we came from three equations to find the three currents to two equations with the two unknowns. And this is actually the concept of mesh analysis, is to write KVL. So this is KVL and this is another KVL. So to write KVL to each mesh or to each mesh in the circuit, and then you can find all other currents in the circuit. So and this is actually, now if we look at this circuit, let me magnify this one now. So it's the same circuit, same voltage sources, same resistances, but now I will not say I1, I2, I3. I will assign mesh currents. So this is a mesh current. IA is a mesh current, IB is a mesh current, and always assign them in the clockwise direction. So you need to assign them in the same direction in the circuit. I advise you, and to be compatible with all the text box in this calculation, to assign the mesh currents in the clockwise direction. Can you assign them the opposite? Yes, you can. Yes, you can. But let's go with the textbook and assign them always in the clockwise direction. So if I assign them, now I want to, please listen to me carefully. So this voltage source, if you go with this direction, will be in the direction of voltage rise, right? And it will be minus V1. But if you take it to the other side of the equation, it will be V1. Now I want to write the voltage drop across this resistor. So what will be the voltage drop across this resistor if you know that IA is flowing in this direction? So in the chat box, it says IAR1. It's right, correct, thank you. So if the current IA is flowing in this direction, so the voltage drop here will be IA times R1. And then I'm going down in this direction. And here we need to pay maximum attention, please. Please pay maximum attention. So here in R3, two currents are flowing, two mesh currents are flowing. I1 is flowing in this direction from up to downward, while IB is flowing from this point and upward. So in this current, we have IA is flowing and IB, and they are in opposite direction. So I'm writing KVL to, the correct answer in the chat box. So I'm writing KVL for IA. So I'm writing IA multiplied by R3. And at the same time, I need to do minus IB multiplied by R3. Or if I want to make it more clear, so the current which is flowing here downward, it will be IA minus IB. Or the current which is flowing upward, it's the same current, but different direction, it will be IB minus IA. So why I'm saying IA minus IB downward, because IA is flowing downward while IB is flowing upward. And this is why I'm writing the voltage drop as R3 times IA minus IB when I'm writing KVL to the left-hand side mesh. While if I want to write KVL to the right-hand side mesh, so I start with V2, voltage drop, it will be positive V2. If you take it to the other side of the equation, it will be negative. So I'm going now in this direction, upward, and the current which is flowing upward is IB, but at the same time, I have another current which is flowing downward, so it will be IB minus IA. So IB minus IA multiplied by R3, which is this current, this voltage drop, and I have R2 multiplied only by IB. So this is how to do the two equations. So as you see, the first equation, sorry. So as you see, the first equation for the first loop and the second equation for the second loop. Here, if you want to rearrange the parameters, so you take IA times R1, and from here IA times R3, so it will be IA times R1 plus R3, and the minus here we have IB times R3, so minus IB times R3. For the second equation, we have IB multiplied by R3 and R2, so IB R2 plus R3, while here we have negative IA R3, which is negative IA R3. Any questions on this example, please? So this, please listen to me carefully. This is how to verify whether you have written the equations correctly. So this equation is for loop A, and the other equation is for loop B, okay? So for loop A, so IA will be multiplied by all resistances in the loop. So we have R1 plus R3. As you see, IA multiplied by R1 plus R3. And for loop B, the current IB will be multiplied by all resistances in the loop B, which are R3 and R2. So IB is multiplied by R2 plus R3. The common resistance will be with the negative sign and multiplied by the other current. So for loop A, I have common resistance R3. It will be with negative sign multiplied by the other current IB. If you write for loop B, so the common resistance R3 will be multiplied by the other current with a negative sign minus IA. So I can, once you have written the two KVLs, you can verify whether these equations are correct or not. Well, this will come by experience, it will come. So don't rush, it will come by experience. Okay, any questions so far, please? Any questions on this slide, please?
No questions.
No, none from me.
Okay, is it clear, please?
Yes.
It is. Yeah.
Okay. So now let's go to an example, and this example is actually the same example that we have, but we will not go with KCL and KVL, and then we will go directly to the loop analysis. So as you see here, how many branches we have here? How many essential branches we have? How many essential branches? In the chat, it says 3, right? So we have one branch, another branch, and the third branch. So we have 3 branches. Sorry. So we have 3 branches. How many essential nodes we have?
2.
2. Okay, so the formula says BE minus NE minus 1. So BE is 3 minus 2 minus 1, it will be 2. So I need 2 equations to solve this circuit using mesh current analysis. So I need 2 equations. Okay, so the first thing I need to do to make sure that this circuit is planar, and I see that the circuit is on the plane on the page, or on the screen of the computer, and there are no crossing lines. So there are no lines which are on the top of each other. The second issue that I need to assign the meshes. So this is the first mesh, the left-hand side, and this is the right-hand side mesh. And I will give the mesh currents IA, IB. You can use numbers, you can use letters, whatever convenient for you. So here we have IA, IB, and the direction of this current is in the clockwise direction. Okay, so make sure that you make all of them in the clockwise direction. Okay, and now we need to write KVL. Going with the voltage rise, it will be negative V1. Taking negative V1 to the other side of the equation, it will be positive V1. The voltage drop here is R1 IA. This is the voltage drop. And the voltage drop in R3, it will be R3 times the current which is going downward. And the current going downward is IA minus IB. So it will be IA minus IB R3. Writing KVL for the other mesh. So starting from the voltage source going downward with the voltage drop will be plus V2. Taking it to the other side of the equation, it will be negative V2. And now I want to write this voltage drop, sorry. I want to write this voltage drop. And this voltage drop is R3 multiplied by the current, which is going upward. And the current going upward is IB minus IA. So it will be IB minus IA multiplied by R3. And for this voltage drop, it's simply IB times R2, IB times R2. Now, if I rearrange the formulas, so IA is multiplied by R1 plus R3, while negative IB is multiplied by R3. Here I have negative IA is multiplied by R3, while IB is multiplied by R3 plus R2. So R3 plus R2. Solving this equation, I will know IA and IB, and I see that IA, if you look at R1, R1 is I1, and the same here, IA is the same as I1. So IA will be equal to I1. In this branch, I2 will be equal to IB, and the I3, which is going downward, so downward, it will be IB, IA that is going downward. I3 is going downward, I'm repeating, so it will be IA that is going downward minus IB, which is going upward. So I3 is equal to IA minus IB. Any questions, please, on this slide? Is it clear, please?
Yes.
Okay. Let's have this example, please. So in this example, let's look at the circuit first and examine it, okay? So how many simple circuit elements in this circuit?
Seven.
Seven. Okay, is it active or passive?
Active.
Okay, active because we have at least one source. Okay. How many branches, essential branches we have? How many essential branches we have?
5.
5. We have 5 essential branches. Okay. How many essential nodes we have? We
3.
have 3, right? 3. Okay, 3 minus 1 will be 2, and 5 minus 2, it will be how much is that? 5 minus 2, it will be 3,
3.
right? Yes. Okay. 5 minus 2, it will be 5. Okay, so you can use the same formula, but without having the essential. So branches here, it will be 1, 2, 3, 4, 5, 6 up to this node and 7. So if we, you need to calculate the branches without having looked at the essential ones of them. So the total is 7. And if we calculate the nodes, so here we have 1, 2, 3, 4, and the lower one is 5. So the total nodes will be 5. And 7 minus 5 minus 1, 5 minus 1 is 4. 7 minus 4, it will be 3. So I can solve this equation using mesh analysis by 3 equations, But if you want to solve it using nodal analysis, how many equations you need? How many equations you need to solve it using nodal voltages analysis?
2.
2, right? Because we have 3 essential nodes, 1, 2, and the lower one. And if you select one of them to be reference, then you need to have only 2 nodes to solve, B1 and B2. Okay. Now, once we examine the circuit, so let's go and see how to solve it. So first of all, we need to assign the mesh currents. So we use this mesh, and this mesh. And as you see that you need to select the loops which have no loops inside them. So this is very important. So we don't use this loop. We don't use this loop. We need to use you need to use the inner loops, And as you see that there are 3 left-hand side, the middle one, and the right-hand side. So we have 3 loops, and according to the equation, we should have 3 meshes or 3 loops that will not have any loops inside them, which we call them meshes. Okay. So is it clear for all of you? How did we find or how did we assign these meshes, please?
Yes.
Okay, and as I told you that you need to use the clockwise direction for the meshes, and you use any numbering system. So in this case, we have A, B, C. We have A, B, C. And now we need to write KVL, and we will start with this mesh. So going upward in the direction of the clockwise direction, so we are going with the direction of voltage rise, and voltage rise means negative. So the first thing, it will be negative 40. So negative 40. Then we will have 2 times IA, and then we will have 8 times what? 8 times what?
IA minus IB.
Okay, and why is that?
Current flow.
Yes, this is the current flow, but can you elaborate more, please?
They're going opposite sides and
Right, opposite directions, but we're focused on the loop that the
Yes.
focus is IA.
So IA goes in the direction, right? While IB is in the opposite direction, right? So the current which is flowing downward here, the current which is flowing downward will be IA minus IB, right? So this will be IA minus IB. So we have negative 40 plus 2 IA plus 8 IA minus IB is equal to 0. Now let's go to the middle, and we will start with this component. So here we have this component 8, and I need to multiply it by the current which is going upward, because the direction of IB is in this direction. So the current which is going upward is IB, as you see, minus IC, because IB is in the direction upward, while IA is downward, then it will be IB minus IC. So this is the first term, 8 IB minus IA, sorry, IB minus IA. And here, the second component is 6. And in 6, we have only IB. is flowing. Then it will be 6IB. And the third component is this component, and we need to see what current is flowing downward. The current is flowing downward is IB, because IB is flowing downward, minus IC. IC is going upward. So then it will be 6 times IB minus IC. So this is 6 times IB minus IC. Is it clear for all of us?
Yes.
Okay, now write please KVL to the third node, to the third mesh. Write please KVL to the third mesh. Write please KVL to the third mesh. So you need to multiply 6 by the current which is going upward. You need to multiply 4 by the current which is going in this direction. And you need to see whether 20 volt will be negative or positive. Done. So 6 will be multiplied by what?
IC minus IB.
IC minus IB and Q. 4 will be multiplied by what?
IC
IC. 20 will be positive or negative?
positive.
Positive. Thank you so much. Okay, so this is the last equation. 6 times the IC minus IB, 4 IC, 20 positive equal to 0. Now you can rearrange the formulas. You take the constant to the other side of the equation. You put IA in this column, IB in this column, IC in this column. So you can solve this system using Kramer's rule or matrix algebra. So if you see in the first equation, let me clear the screen first. Let me clean the circuit first. And if you remember that in the previous example, I told you about the numbers. So IA, this KVL, first KVL is written for A, the second KVL is written for B, and the third KVL is written for C. If you look in loop or mesh IA, how many are the resistances, the total resistances in this loop, how much? What is the total resistance in this loop? So we have 2 here, and we have 8.
Is it 10?
It is 10. So here it is 10. What will be the total resistance here in this loop?
Twenty.
20?
20. And which current? IB, right? So you see 20 IB. What is the total resistance here in this loop?
10.
10. You see 10 IC. So each current, if you write to C, so this current will be multiplied by the sum of the resistances in the mesh, and similarly for B and C. Okay, so what is the mutual resistance between mesh A and the mesh B? What is the mutual resistance between mesh A and mesh B?
8.
8, and this will be with negative sign multiplied by IB. What is the mutual resistance between IA or loop A and loop C? What is the mutual resistance between mesh A or loop A and
0.
loop C? 0. So we have 0 IC. Okay, so what I want you to do, of course, if you write KVL correctly, you will come to this form of equations. But if you give these equations more time to examine and to have a look and to compare it with the circuit, you will find some interesting characteristics that will help you to verify your answer when you write KVL for this loop. So as you see, we have the three equations with the three unknowns, IB, IC, and if you solve them using whatever method, so IA will be 5.6, IB will be 2, and IC will be negative 0.8, negative 0.8. Now we need to find, it says find V0, and what is V0 equal to? What do you think? So this is the plus, this is the minus. So V0 will be 8 times the current, which is going downward, right? I will say I0 times I0. And what is I0 in terms of mesh currents? What will be the current flowing downward?
IA.
IA
IA
Only?
minus IB.
IA minus IB, IA minus IB. So in this branch, we have two currents, right? This is IA going like this, and IB is going like this. So the one which is going downwards is IA minus IB. And I know IA and IB, so the difference between them is 3.6. So the voltage which is required by the examiner is 28.8. Any questions, please? Any questions? Is this method clear, please?
Yes.
It is for
Okay.
me.
Yeah.
So this will be homework number, I guess, 5. This is homework number 5. I will post it and I will give you a week to solve it, although it won't require more 1 hour to solve it. So, and let me see what we have else here. Okay, so we have the voltage sources and the super mesh. Okay, so let me go back. And in the last few minutes that we have 10 minutes or 12 minutes. So let's discuss the homework. So in this homework, how many branches we have? How many branches we have? So I see one answer by Travis and
Yes, 6.
6. So 6. So why the other are silent? You don't know how to calculate the branches in this circuit? Please tell me who can calculate the branches in the circuit. Let me ask, do you know how to calculate the branches in the circuit?
Yes.
More responses, please.
I think so.
Okay. 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 So the branch is the path from one node to another node, from one node to another node. So this will be one branch. This will be another branch. This will be there, branch number 3. This will be branch 4. This will be branch 5, and this will be branch 6. So we have 6 branches. Okay, how many nodes I have in this circuit?
4.
4. So this one, this is another one, this is another one, and this is another one. So I have 4 nodes. Okay, how many essential nodes I have in this circuit?
4.
4, because essential node is an interconnection between 3 or more elements. So for this, I have 1, 2, 3. 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 So all the nodes I have are essential. I don't have any nodes that connect only 2 elements. So all the nodes I have essential. Okay, how many essential branches I have?
6.
6. So what is the difference between the branch and the essential branch?
Is the connection between 2 essential nodes?
Yes, so the branch is a connection between 2 nodes. The essential branch is the connection between 2 essential nodes without passing any other essential node. So this is essential node and this is essential node. So this will be branch. This is essential node, this is essential node, this will be branch. So if we calculate them, so this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. So we have the same number. All branches we have in this circuit are essential, or nodes in this circuit are essential as well. Okay, let's apply the formula PE minus NE minus 1. This is equal to BE is 6 minus 4 NE minus 1, it will be 3. So we need to have 3 equations in order to solve this method using the mesh currents, the mesh current method. If you want the mesh current method, you need to have 3 equations. Okay, if you want to use a node voltages method, how many equations you need to have?
3.
3. Why is that? Because
We
we
just
yes, go ahead.
because we just use essential node minus 1.
Yes, because we have 4 essential nodes. 1 will be reference. Then we will have 3 nodes, essential nodes, non-reference essential nodes, and we need to write the 3 equations. Okay, so for voltage, I will write here node voltage method. It will be also 3. It will be also 3. Okay, by experience so far, what do you prefer? Do you prefer node voltage method for this circuit or mesh current method?
Mesh current.
Mesh current, okay. Other opinions?
Mesh.
Mesh, so I have also mesh also. Okay, so all are with mesh. Okay, so all are with mesh. So I will go with node voltage method if I have the choice. Why is that? Because as you see, I have a special case here. I have a voltage source that is connected between 2 essential nodes. So if I select this as a reference node, then V1 will be known as 80 volts, and I don't need to write an equation for V1. Then I need to write KCL twice for this node and this node, right? So I can take advantage of the fact that I have a voltage source connected between essential node, and then I will use only 2 equations. Is my point clear, please?
Yeah, very clear.
Yeah.
Okay, but we will use mesh analysis because the examiner asks us to use mesh current method, although node voltage method here is more appropriate. So the first step we need to do, we already calculated the number of equations. The first step we need to do to check if this circuit is planar or non-planar. Is it planar or non-planar?
Plan.
Planar, because it is drawn on a plane and we don't see any lines crossing each other. Okay, it's a planar. Okay, according to our formula, we need to have 3 meshes. So where are the 3 meshes? Do you see them?
Yes, I do.
Yeah.
Okay, please describe one of them, please.
I guess left, bottom left would be Negative 80.
Okay, so this is negative 80.
That'd be plus 5 IA
Okay,
plus 26 IA. Well, technically, if you put 3 on the other side,
okay, so 26
Sorry.
IA minus something, right?
yeah, it'd be
So-
26 times IA minus IC.
Okay, okay. So this is the first mesh, right? I put IA for the first mesh. So where is your second mesh?
On the top.
On the top, you decide that this will be the second mesh, right? And as you see that, so this will be IB. And as you see that all the direction should be in the clockwise direction. And where is the third mesh?
The bottom right.
Bottom
see.
right. Bottom right, so it will be IC like this. Sorry. Sorry. So this will be IC, right? Okay, so now we need to write 3 KVL, and after writing 3 KVL, you will have 3 equations with the 3 unknowns IA, IB, IC, and then you can solve this system of equation, find IA and IB and IC, and let's see what we need to do here. Use the mesh current method to find the power delivered by the 80 volt. So in order to find the power, you need to multiply the power by IA. So you need to find IA. And the power dissipated in the 8 ohm resistor. And here is the 8 ohm resistor. In order to find the power, you need to multiply 8 by IC square, because this is how to find the power. So these are the answers that you need to achieve. You need to achieve. So if I want to write KVL with you in the last minute, so if for this loop, it will be negative 80. And here I have 5 multiplied by A and minus IB, right? So a little bit earlier, we describe it incorrect. So it will be IA minus IB, right? Is it clear for all of us? Why
Yeah.
okay. And this current will be 26. So this will be plus 26 times IA minus IC. So this will be the first KVL written to IA, right? And then you need to write the KVL for IB. You see that you have 30 multiplied by IB, but 5 should be multiplied by IB minus IA. And here 90 should be multiplied by IB minus IC. And then the third KVL, you need to 90 multiplied by IC minus IB, 8 multiplied by IC, and 26 multiplied by IC minus IE. So you will have a 3 KVL, 3 equations, straightforward problem that you can solve it and find the power. So this will be homework number 5, and I will give you a week for that. Any questions, please? Any questions?
No.
Okay, so if you don't have any questions, we came to the end of the class. So I hope that this method is clear so far. And next class, we will continue with this method. So see you after tomorrow.
Thank you very much.
You are most welcome.
Thanks, Professor.
You are welcome.
Thank you, Professor.
You're welcome.